Hello. Today I want to talk about how to use UTM coordinates or a grid reference to identify a location on a map. So I'm only going to talk about the things that we actually need to be able to use them, when we're out walking in the mountains. So you won't hear me saying anything about, well, apart from now, central meridians or spatial reference systems or Cartesian coordinates or any of the other complicated stuff. In this video, I'm only interested in the information we need to be able to use UTM coordinates or grid references, when we're out walking in the hills and mountains. The first thing to mention is that from the point of view of somebody navigating around the hills or mountains, the two systems, UTM coordinates and grid references, they're basically the same. They use a grid in which each line has been given a number or a letter. The numbers or letters that go across the map refer to the columns to the right or the east of the vertical line, and the number or letters that go up the map refer to the row above or north of the horizontal line. Here's a very important thing to remember. Regardless of whether you're using UTMs or a grid reference, you always read the numbers or letters which go across the map first, and then the numbers which go up the map. There's a saying which, might help you remember: along the corridor, then up the stairs. By saying which column or row covers your location, you can let other people know where you are. And obviously, the thinner the columns or rows, the more accurate you can define a location. Oh, and both systems, at first they may appear difficult to use if you're not used to them. But as long as you forget all the complicated stuff, which honestly I promise not to mention anything complicated today, they're both really simple to use. I'll give you an example. Let's say that you and I are flying to the moon for some strange reason, and we want to arrange to meet after we've landed. So we agree to meet at this crater. And here's a map of the area around the crater. Now, if you look at the map, you'll see there are numbers along the bottom which increase as they go east. So these are called eastings. There are also numbers on the side of the map, and they increase as you go north. So they're called northings. Now, just for now, we'll assume that the lines are 1 kilometer apart. So the grid, it forms squares which are 1 kilometer on each side. Now, if we look at the numbers along the bottom of the map, we can see that our crater is in column 4. Then we go up the map and we read at the side of the map, we can see that our crater is in row 3. So when we join these two references together, we can say that our crater is somewhere within 4-3. But as you can see, there's more than one crater in 4-3. So to identify our crater, we need to be, more accurate. So we'll need to divide that 1 kilometer square, which is 4-3, into 100 meter squares like this. So you can see that our crater is in the 100 meter column number 3, and it's in row 7. So now we know which crater we're going to meet in, and on the map it's at 4337, and this is correct to within 100 meters. Now we could divide each 100 meter square into 10 meter squares, and then divide those smaller squares and keep on doing this until we had a very, very precise location. But normally when you're out walking in the hills and the mountains, giving your location to within 100 meters or 10 meters, that's normally enough. I made a video, by the way, when I went to find the exact 1 centimeter square, which is at the very center of Great Britain. I made a video. I'll put the link in the description box. Anyway, but obviously there are lots of maps covering each zone on the moon, and they will all have the same, type of numbering, and they'll all have a square 4337. So to identify our specific crater, we need to say which map we're using. And as you can see, our crater is within the area covered by map G. So if we were using a UTM system, we would say that our UTM was G43 east, 37 north. If we were giving a grid reference, we would say that our location is at G043037. So grid references and coordinates both use numbered systems, to identify a specific location. You know, it's as simple as that. I told you it was really simple. That they do look complicated, you know, if you're not used to them, especially UTMs, but they are really simple. There are some differences, obviously, between the two systems. So the main one is that UTMs, oh, by the way, UTM stands for Universal Transverse Mercator. You can imagine the UTM system as a grid of 1 meter squares which covers the entire world, other than the regions around the North and South Poles. They have a different system. And a grid reference is it's the same. It's the same type of grid, but it can be used to identify a location in which a government has created a national grid. So as I'm in the UK, I can use either a UTM coordinate or a grid reference. You know, both of the systems would work in this country. But here's a really important point to understand. With both grid references and UTMs, if you want to tell somebody a location, you know, you want to identify it to them, it's really important, I'll say it again, it's really important that you tell them in a way that will allow them to know which location you're talking about. So you have to say it correctly. As an example, I'll tell you where I am now. You may be wondering, by the way, why I've come to this spot in the middle of nowhere. I'll tell you. My grid reference now is 1, 2, 3, 4, 5, 6, 7, 8. I do plan these videos, you know. Anyway, that's my grid reference at the moment. 1, 2, 3, 4, 5, 6, 7, 8. So even though I've given you my grid reference, do you know where I am? No, you don't. If you remember on the moon map, I had to tell you which map I was using, and it was map G. And it's the same in the UK. If I don't tell you which map I'm using, I could be in any of 59 different locations, which all have the same grid reference numbers. And it's also the same with my UTM. At the moment, I'll put my UTM on the screen so you can see it. Okay. Now, if I haven't told you which zone I'm in, I could be in any of 120 different locations, all of which have the same UTM numbers. So UTMs and grid references have to be given in a way that someone will be able to identify that location. So let's have a look at how we can use grid references and UTMs. Oh, just one thing before we start. There's a very simple way that you can use your compass to very accurately measure UTMs and grid references, and I made a video about it. I'll put the link in the description box. If you go walking out in the hills and mountains using a map, I would suggest that you watch that video, you know, just to make your life easy. So let's start with UTMs first. Now, I have to admit that UTMs, if you're not used to them, they can appear complex because of the large numbers. As an example, I told you my grid reference here was 1, 2, 3, 4, 5, 6, 7, 8. So that is an 8-figure grid reference, and it identifies my location, you know, down to 10 meters, you know, 10 meters of accuracy. If I wanted to give you my approximate, you know, position, say to within 100 meters, then my grid reference would be 1, 2, 3, 5, 6, 7. So it's a 6-figure grid reference. So the less accurate the grid reference is, the less digits are used, the less numbers. But with a UTM, you always need to give the full set of numbers. So I'll put my UTM onto the screen so you can see exactly what it is. Now this gives you my location to within 1 meter. If I wanted to make it less accurate, say to within 10 meters, it'd be this. And if I wanted it to be within 100 meters, then it would be this. So have you noticed that all I'm doing is that I'm replacing the last digit with a 0, and the less accurate, you know, the UTM is, I replace more of the UTM with zeros at the end. But the number of digits always stay the same. So it can seem complex, but I'll try and prove to you that it's not. Now, if you remember, I said that to identify our crater on the moon, the first thing we had to do was identify which map we were using, and it's the same with UTMs. So the UTM system divides the world into 60 zones, which stretch almost from the North and South Poles, and each zone has a number. So at the moment, I'm in zone 30. So my full UTM is 30, 378, 201 east, 598, 5484 north. Let's do a couple of real examples. So here we have a map of the Squaw Pass area in Colorado, which is in the USA, and I want to give the UTM of Beaverbrook Reservoir number 3A. Now, we can use the map scale and to see that it's over 200 meters long, so we only need to give a very general location for it and somebody will be able to find it. And in the index, it shows that this map is in zone 13S. The S is just the letter which that row has been assigned. Most people don't use them, and as long as you know which zone you're in and whether you're north or south of the equator, everyone will understand if you just say zone 13. Now, depending on what type of map you've got, you should look in either the top or bottom corner of the map and you will see a number like this. In this case, it's 458000. Moving across the map, you'll see 459, 460, 461, etc. And that's the same type of easting, but the last three digits, the 3 zeros are not shown. So we can see that the reservoir is in column number 462. Next, we look on the side of the map and we can see 4387000. So moving up the map, we can see that the reservoir is in row 4393. Again, the last three digits are not shown. As the lines on the map are 1 kilometer apart, the UTM of Beaverbrook Reservoir number 3A is, to within 1 kilometer accuracy, 13 462 000, 4393 000 north. Now, obviously, most of the time you're going to have to give someone a more accurate location than saying something is within a 1 kilometer square. So let's say that I've decided to go camping overnight. And let's say that I'll be camping here on the left-hand side of this stream, and I need to tell someone where I'll be, just in case there's any problems. So looking at my map, I can see that I'll be in zone 12, and the numbers at the top of my map start at 716000 east. And my column, my campsite is in column 721. So the easting, just to the left of my campsite, is 721,000 meters. But using the scale on the map, I can see that my campsite is 290 meters to the east of that line. So I need to add this to the line's number. This means that the campsite's easting is 721000 plus 290 equals 721290 east. I also need to do the same thing with the northing, which is at 4343. The campsite is 660 meters above the northing, and 4343 plus 660, the northing for the campsite is 4343660. So the full UTM of my campsite is 12721290 east, 4343660 north. And that's it. So even though UTM coordinates may look complex due to the large numbers, they actually are really simple to use. But just don't forget, it's the zone followed by the easting followed by the northing, and that's UTMs. Next, we'll look at grid references. Now, grid references, as the name suggests, it's basically a reference to an area on a grid, and they're used in the same way as UTMs. But as I said, they can only be used in an area where a country's national mapping agency has actually mapped their own country using a grid system. Now, obviously, UTMs will still work in those countries, but here in the UK, I have never once, ever, whilst I've been out in the hills, heard anybody using a UTM coordinate. Everybody uses Ordnance Survey grid references, and I assume it's the same in lots of other countries. They use their own grid systems. Now, like any type of mapping, grid references, if you look into them in too much detail, they can get very complex. But for people walking out in the hills and mountains, it's always better to keep things as simple as possible. That way they're less likely to go wrong. All you really need to know is how to find a grid reference on a map and how to tell somebody what that grid reference is. And you need to tell them in a way that they will always be able to identify that location. So you need to say it correctly. Anyway, let's just get it straight into this. The Ordnance Survey has divided Great Britain up into squares, which are 100 kilometres on each side. So each square is identified by 2 letters. Now, at the moment, I'm in the square SE. These 100 kilometre squares have vertical and horizontal lines every 1 kilometre. So they form a grid of squares which are 1 kilometre on each side. These are the blue lines that you can see on your map. Each vertical line has a number at the top and the bottom, and these numbers show how far in kilometres that vertical line is from the westerly or the left edge of the 100 kilometre square. As they increase as you go east, these are called eastings. The number on the horizontal line, which are printed on both sides of the map, show you how far you are from the bottom of that 100 kilometre square. And as they increase as you go north, they're called northings. And these numbers are also printed inside the map at various intervals. You can use these 1 kilometre grid squares to give the location of something. As an example, Buckingham Palace is 29 kilometres from the westerly edge and 79 kilometres from the bottom of the TQ 100 kilometre square. So it's in the 1 kilometre square grid TQ 2979. This is known as a 4-figure grid reference. For something like Buckingham Palace, saying it's somewhere within a 1 kilometre square, that'll be close enough because, if you're in that area, you will be able to see Buckingham Palace. Take it from me, it's big. I've never been inside, by the way. I've never been invited inside for tea. I've just stood outside with everybody else. So, normally when you're out in the hills and the mountains, you need to be more accurate than saying I'm somewhere within this 1 kilometre square. You need to be, more precise. So what you can imagine doing is dividing the 1 kilometre square into 100 metre squares. So if that was the case, at the moment, my grid reference would be SE 12.3.56.7. If you were to write that number down, that grid reference, it doesn't really matter how you do it. As long as the 2 letters and all the numbers are there, people will still understand it. But if you're saying a grid reference, it's different. It has to be said in a certain way. I'm trying to think about how to say this non-technically. The first 2 numbers are integer and the rest of the numbers are fractional. So it's starting to overcomplicate things again. So as an example, I wouldn't say SE 123.567. You just don't say that. What you would say is SE 12.3.56.7. That way everybody will understand it. It might help if you think about it as the number as a decimal. So SE 12.3.56.7, but don't say the word point. So it's just SE 12.3.56.7. Now, in the last example, in that grid reference 12.3.56.7, that describes an area which is 100 meters on either side, 100 meters square. Now, if you were to divide that square again, by 10 on each side, you would have smaller squares which were only 10 meters wide. And this is an 8-figure grid reference. And my particular location at the moment is, it's not SE 12345678. It is SE 12345678. So you always need to say grid references, like that. Now, if you're out walking with friends or someone knows exactly where you are, you don't really need to give the SE. Just give them the grid ref, just give them the numbers. But if it's for something important, you're calling the mountain rescue team or something like that, it's better to be safe than sorry, so give them the full grid reference. Ordnance Survey maps always show the designation letters of the maps in the top corners. I've got a few maps here, I'll show you. This one is NN, this one is NY, and this one is SE. So I hope you understand that even though UTM coordinates and grid references use different systems, from our point of view, somebody walking around the hills and the mountains, they're basically the same. You go along the corridor and up the stairs. or as the Americans say, read right then up. So you first identify the zone or the map that you're on, and then you read the numbers going across the map, and then that's the eastings, and then you read the numbers going up the map, that's the northings. So thanks for watching.